Hello everyone, welcome to day 5th of March Leetcode challenge and I hope all of you are having a great time. The question that we have in today is delete and earn. Here in this question we are given an array of integers and you need to identify the maximum points that you can earn out after applying certain set of rules. As per the rule, if you pick up a number, you get as many points as the value of that number. However, you after picking up that number, you cannot pick up any other number of value element minus 1 or element plus 1 if they exist in the input array. Here they have specified us with few examples. I'll be walking you through these examples by the presentation. So let's quickly hop onto it. Delete and earn Leetcode 740. It's a medium level question on Leetcode and I totally feel the same. So let's get started. Here I have taken a slightly longer example so that you get a good hold of the concept. The elements that I have is 3, 4, 2, 7, 6, 9, 6, 13, 7, 8. And let me just write that rule. If you are picking up any element, you get these many points as the value of that element. However, you cannot pick the adjoining or adjacent elements to this element, which is element minus 1 or element plus 1 from the input array. For example, if you are picking up 7, then you will definitely get a score of 7 units. However, you can't go for 6 or 8. So remember this and let's apply the algo. In the first go, what I'm gonna do, I'll create the frequency map so that I'm aware of what all elements are present and at what all frequencies it exists in my input array. So let's get started. 0 is not present, 1 is not present. We have 2 here, so let's add 2. We have 3 here, let's add 3. We have 4 here, let's add 4. So these are gone. And next we have is 6. So 5 is 0. We have 6 at 2 places. This one and this one. Then we have 7 at again 2 places. This one and this one. Then we have 8. Then we have 9 and followed by 13. So all of these are 0. We have 13 here. Now we will be using this frequency map to actually compute our answer. How? Let's have a look at it. Also in the question it was specified that the elements would lie up till the range of 1 up till 10 raised to the power 4. It's an important constraint that most people tend to miss out. Do remember this point and we will be using or exploiting this property to actually derive at the solution. So let's get back. What we are going to do, we will be using the pre-computed values in the past to actually come up with the solution, and whenever we have pre-computed values usage in the past, the solution points to dynamic programming. We will draw analogies of this question with the house robber series and you will agree with me that it's an exactly same question. How? Let's have a look at it. So what we are going to do, we'll create the DP array for each element of the index starting from 0 up till 10 raised to the power 4, and it will signify the maximum score corresponding to that index. So let's hypothetically assume that we are standing at the ith index as 6 right now, and we have already computed the scores in my DP array for I minus 2 position and I minus 1 position. Now as per the question, if you want to pick up this particular element, the ith element, what all options do you have? The first and the foremost option is to skip this element. Let's absolutely skip it. So one possibility of score for the ith location will come from DP of I minus 1. What is the other possibility? If we are thinking that let's pick up this element, we have considered the skip case. Now let's select this element. What we will do, we'll go to 2 positions back, 1, 2, and whatever score you have calculated, we will be exploiting this score to actually find the score when we pick up this element. That would be equal to DP of I minus 2 plus what current index are we at? We are at 6 index. So I represents that index into the frequency or the number of times that element occur in my input array, because these two will contribute to the total score, as we have 2 6s in this input array. As a result of which, the total score by virtue of this addition will be 12, 6 into 2. Without further ado, let's quickly build our solution score or DP array. Let's get started. We'll start from the 0th index. What do we have? We have 0, so let's skip, the score becomes 0. Next we have is 1. So what is the previous score? The first option you pick up from the previous value, it's 0. The frequency is again 0, so it will be 0. Let's forget it. So far we are so good. Let's proceed ahead. Next we see is 2, and at 2 we have frequency as 1. What is the first possibility of solution? First possibility comes from the previous score, which is 0. The other possibility comes from, you go back to two places. So you go back to two places. What is the score? Score is 0 plus what is the current element? The current element happens to be 2. 2 into 1. What do you get? 2. The maximum out of these two is 2. So the score corresponding to this particular location turns out to be 2. So let's write 2 here. Let's proceed ahead. Next we see is 3. So the frequency for 3 is 1. Let's calculate both the possibilities, and let me just change the color of pen. One possibility comes from the previous score. So we have one possibility as 2. The other possibility is, you go back to two places. What is the score there? Score is 0. So we have to choose the maximum of 2, 0 plus 3 into 1, which is 3. So maximum of 2, 3 is 3. So the score corresponding to this location turns out to be 3. Let's proceed ahead. Let me just change the color of pen. What are the two options available? What is the previous score? The previous score is 3. What is the current value? The current element happens to be 4. What is the frequency? 4 into 1. So this will give me 4, and don't forget to go back to two places. What is the score here? The score here is 2. So 4 plus 2 gives me 6. So we have to choose the maximum out of these two. Out of 3 and 6, the maximum value is 6. So the score becomes 6 for this particular index. So far so good. We are applying the same process at each and every index. Let's proceed ahead. Next we see is 5. So at 5, what are the two possibilities? You go back to the previous location. What is the score there? The score there is 6. What is the other possibility? You go back to two positions. You go back to 3. At 3 the score is 3. So out of 6 and 3, and the frequency here is also 0, so it will not contribute to any addition. Out of 3 and 6, the maximum value happens to be 6, as a result of which score here becomes 6. Let's proceed ahead. Next we see is 6, and the frequency at 6 is 2. So what is the first possibility? You go back to the previous location. The score here is 6. What is the other possibility? You go back to two previous locations. The score here is again 6. What is the current frequency? The current frequency is 2. So 2 into 6. What does it give? The maximum of 6 and 18 gives you 18, and the answer here becomes 18. Let's proceed ahead. Next we see is 7, and the frequency here is 2. So what are the two possibilities? The first one happens to be 18, and the other one happens to be, you go back to two places. 5. What is the score here? The score here is 6 plus 7 into 2, which is 14. So out of 18 and 20, which one is the maximum one? 20 is the maximum one. So the score here becomes 20. Let's proceed ahead. Only few options are left. I'll quickly wrap up on those. The next element that we see is 8. So what is the first possibility of the answer? You go back to the previous location. What is the score here? The score here comes out to be 20. So the first possibility is 20. What is the other possibility of answer? It comes from going back to two places. What is the score here? The score here is 18. 18 plus 8. So out of 20 and 18 plus 8, 18 plus 8 comes out to be 26. So out of 20 and 26, which one is the maximum value? 26 is the maximum value. So let's write 26 here. The score corresponding to 8 is 26. Let's proceed ahead. Let me just change the color of pen. And what is the first possibility? First possibility comes from skipping 9. So it turns out to be 26. What is the other possibility? You go back to two places. Corresponding to 7, what is the maximum score? The maximum score is 20. So 20 plus 9. So out of 26 and 29, which one is the maximum one? 29 is the maximum one. So the answer corresponding to 9, or the maximum score up till 9th index, comes out to be 29. Let's proceed ahead. Next we see is 10. And what are the two possibilities? The two possibilities are looking for the previous location, which is 29, going back to two places, 8. The score here is 26 plus 0. So out of 29 and 26, the answer becomes 29, which is the greater value. Let's proceed ahead. Next we see is 11. At 11, what do? We check the previous value, it's 29. You go back to two places. At 9, the value is again 29, and the frequency here is 0. So out of 29 and 29, the maximum value is 29. Similarly, the maximum value again would be here 29, because both the values in the past is 29, 29 each, and here the frequency is 0. Now comes the last index. Again, let's do the same thing. What we are gonna do, we'll simply look out for the previous value, which comes out to be 29. And what is the other possibility? You go back to two places. At 11, what is the score? Score is 29. What do? You add 1 into 13. What do you get? You get 29 plus 13, which is 42. So out of 29 and 42, which one is the maximum one? 42 is the maximum one, and this becomes your final answer. So whatever value is held at the last index will give you the final result. I'll highly recommend you guys to go for the house robber series, and you'll exactly follow the same analogy that I have talked here. In that question, there is a robber who cannot rob the adjoining houses, and this equation comes from that question. Had I not solved that question in the past, and for anyone who is looking out to improve the basics of dynamic programming, house robber series is must. The time complexity of this approach is order of n, and similarly the space complexity is also order of n. Here I have created two arrays, one for storing the frequency of each element that is present in my input array, another one for calculating the scores, and that is represented by my DP array. I go ahead and iterate through all the elements that are present in my input array and update my frequency map appropriately. Then moving ahead, I have set the DP of the 0th index to 0 and DP of first index to 1 into frequency of 1. And going ahead, I have created a loop starting from the second index up to 10 raised to 1000, 10,002, and with each iteration, and I'm incrementing the value of I. What does DP of I will have? There are two possibilities, one from the previous index, another one from 2 steps back plus I into frequency of I. In the end, once I'm done with the iteration, I simply return the value at DP at 10001 index. The time complexity as told is order of n, so does the space complexity. This brings me to the end of today's session. I hope you enjoyed it. If you did, please don't forget to like, share and subscribe to the channel. Thanks for viewing it. Have a great day ahead and stay tuned for more updates from Coding Decoded. Also, I'm attaching the link of the dynamic programming playlist in the description below. So do check it out. If you think DP is weak section for you, do give it a shot. Thank you once again.